Picture a museum hall in New York City, glass cases, marble floors, and towering above every visitor, a skeleton 40 feet long, its jaw locked in a permanent, silent roar. For over a century, we've been told this is Tyrannosaurus rex, the most studied, most understood, most solved animal in the history of paleontology. Here's the problem. Almost everything we were told is wrong. Not wrong in a small way. Wrong in the way that rewrites textbooks. Wrong in the way that forces museums to tear down their own skeletons and rebuild them from scratch. We've spent decades treating the T-Rex as a finished story, a predator whose posture, whose face, whose mind, whose size, even whose very identity as a single species was settled science. It wasn't. And in the last 2 years alone, the ground has shifted again, harder than ever before. By the end of this video, you'll understand 6 of the biggest scientific mistakes ever made about the most famous predator to walk the earth. And the final one doesn't just change what T-Rex looked like. It changes how many of them there actually were. So if you think you already know the king of the dinosaurs, stay close. This is where the crown starts to slip. Mistake number 1 starts in that same museum hall in 1915. Paleontologist Henry Fairfield Osborn stands beneath a newly mounted skeleton at the American Museum of Natural History and gives the world its first full-body look at Tyrannosaurus rex. The pose he chooses becomes gospel for the next 70 years. The animal stands bolt upright, tail dragging on the ground behind it like a fifth leg, body held at almost 90 degrees. Less predator, more kangaroo with teeth. That image doesn't stay in the museum. It leaps onto movie screens, onto cereal boxes, onto the gas station dinosaur logo pumping fuel into your car. Picture the tail as a giant fifth limb, thick as a tree trunk, scraping a groove in the dirt with every step, the whole animal balanced like a tripod. For generations, this is simply what a T-Rex looks like. Scientists build the reconstruction the same way anatomists at the time build most dinosaurs, by comparing them loosely to living reptiles and to kangaroos, animals that also stand upright on powerful hind legs. So the tripod posture becomes doctrine, repeated in textbook after textbook, unquestioned for the better part of a century. But here's where it gets strange. Starting in the 1970s, a wave of paleontologists, led by figures like Robert Bakker, begin looking closer at the actual mechanics of the skeleton, and the math stops working. A spine bent upright at that angle, supporting a skull the size of a bathtub, would dislocate its own hip joints under the animal's own weight. The tail vertebrae show none of the fusion or wear you'd expect from constant ground dragging. Therefore, the old kangaroo pose isn't just outdated, it's biomechanically impossible. By 1992, the very same American Museum of Natural History that built the original upright skeleton tears it down and remounts it horizontally, spine level with the ground, tail extended straight out behind as a counterbalance, head thrust forward like the business end of a battering ram. Still, the correction isn't as clean as it sounds. Exactly how far the spine tilted, how fast the animal could move in that posture, even how the tail flexed with each stride. Paleontologists are still refining those numbers today, and pop culture hasn't fully let go of the old silhouette either. Every time a film or a toy leans back into that upright stance for dramatic effect, the myth gets a little more oxygen. So the first mistake about T-Rex wasn't really about the animal at all. It was about how badly an entire century of imagination can outrun the evidence sitting right there in the bones. And if the body itself was drawn wrong for 70 years, what about the face people were staring straight into every time that jaw opened on screen? Mistake number 2, lives in that open mouth. Picture the moment, 1993, a rain-soaked jungle road, a jeep, and a Tyrannosaurus rex lowering its head into frame, upper teeth hanging bare and jagged even with its jaws shut, saliva stringing between fangs the length of a banana. That single shot does more to define the public image of T-Rex than any museum exhibit ever managed. And for 30 straight years, nearly every documentary, toy, and textbook illustration copies it. Permanently bared teeth, crocodile style, no lips in sight. There's a reason that image sticks so hard. From the 1980s onward, paleo artists lean into a fiercer, more monstrous aesthetic for predatory dinosaurs, and lipless jaws simply look scarier. So the exposed tooth look spreads not because a study proved it, but because it sells menace. Therefore, generations of people grow up assuming T-Rex's 12-inch teeth were simply too enormous to ever be covered. Here's the twist. In March 2023, a team led by paleontologist Thomas Cullen, then at Auburn University, working with researchers including Robert Rees at the University of Toronto, Mississauga, publishes a study in the journal Science that tears that assumption apart. They compare the skull and tooth measurements of more than 20 theropod dinosaurs against living reptiles, including monitor lizards and crocodiles, and they trace the tiny nerve and blood vessel openings along the jawbone. The same openings that, in modern animals, reveal whether soft tissue like a lip ever sat over the teeth. The pattern in T-Rex matches lizards, not crocodiles. On top of that, they study tooth wear. Crocodiles, whose teeth sit exposed to open air, burn through as many as 3,000 teeth in a lifetime, replacing each one in about a year. A T-Rex tooth, by contrast, takes roughly 2 years to replace and shows none of that dry, weathered wear. So the researchers conclude that T-Rex's teeth, even the biggest ones, were most likely sheathed behind thin, scaly lips whenever the jaw was closed. A full facelift for the most famous mouth in paleontology. But this isn't an open and shut case, and the researchers are the first to admit it. Some paleontologists still push back, arguing the biomechanics of a fully sealed, lipped mouth are harder to model than the study suggests. And a handful of artists keep drawing the old, exposed grin simply because it's iconic now, evidence or not. The debate over exactly how those lips moved and how visible the teeth really were mid-roar is still very much alive. Either way, the jaw that launched 1,000 nightmares was probably a lot less bare than the one burned into your memory. And if the animal's own face had been misread for 30 years, imagine how wrong we might have been about the way it actually lived. Mistake number 3 is the idea that Tyrannosaurus rex hunted entirely alone. Picture the classic image, a lone titan stalking an empty floodplain, no rivals, no company, answering to nothing but its own hunger. The same lonely apex predator myth that gives its most famous movie counterpart, no pack, no mate, no family at all. That image has deep roots. In 1910, a team from the American Museum of Natural History digs into a hillside in Alberta, Canada, and walks away with fossils from at least 26 individual Albertosaurs, close cousins of T-Rex, all buried together in the same bed of rock. For decades, the discovery sits mostly forgotten, filed away as a curiosity. Then, in 1966, researchers from the Los Angeles County Museum excavating a Tyrannosaurus rex in Montana's Hell Creek Formation find something strange resting right on top of it, the bones of a second individual. More possible multi-tyrannosaur sites turn up in Montana's Two Medicine Formation in the years that follow. So piece by piece, the picture of the solitary hunter starts collecting company it was never supposed to have. Here's the twist. Paleontologist Philip Currie at the University of Alberta goes back to that forgotten 1910 bone bed decades later and gives it the first serious scientific study it's ever received. What he finds is striking. A mass grave of tyrannosaurid relatives, buried together at roughly the same time, in a pattern that looks less like coincidence and more like a group that lived and possibly died side by side. Combine that with the other Montana bone beds, and a growing number of researchers start arguing that at least some tyrannosaurids, T-Rex included, may have spent part of their lives in loose social groups rather than complete isolation. And nothing captures the drama of a T-Rex-era predator locked in a moment of intense interaction, quite like the dueling dinosaurs. A spectacular fossil discovered in Montana in 2006, showing a small tyrannosaur and a triceratops preserved together in what looks like a fight frozen mid-strike, jaws and horns still nearly touching after 66 million years. But here's the honest counterpoint. Not every scientist is convinced these bone beds prove true pack behavior. Some argue the animals could have been drawn together individually by the same trap. A drying mud hole, a flood, a single carcass luring one predator after another to the same fatal spot, rather than living as an actual social unit. Curry himself has called these sites difficult to interpret, and the scientific community remains split on how far to push the word social when it comes to an animal this size and this dangerous. So the lone hunter of pop culture probably wasn't quite so alone after all, even if science still can't say exactly what that company looked like. And once you accept that a T-Rex might have shared its world, its meals, even its territory with others of its kind, a bigger question opens up. What kind of brain would it take to navigate a life that's social? Mistake number 4 is about what was going on inside that enormous skull. In January 2023, headlines around the world start running some version of the same startling claim. T-Rex may have been as smart as a baboon. The source is a study by Susanna Herculano-Hausel, a neuroscientist at Vanderbilt University, published in the Journal of Comparative Neurology. Using fossil brain cavities and comparisons to living relatives like ostriches and emus, she calculates that a Tyrannosaurus rex forebrain may have packed in more than 3 billion neurons. More than a baboon, enough, she suggests, for primate-level cognition, maybe even tool use and the passing of knowledge between individuals. Picture what that would actually mean. A 16,000-pound predator, not just powerful, but calculating, patient enough to plan, curious enough to learn, perhaps even social enough to teach. It's a genuinely thrilling idea, and it spreads everywhere, because for the first time in decades, the dumb lizard reputation that had followed dinosaurs since the 1970s finally seems ready to fall. So the primate-brained T-Rex becomes, almost overnight, the new common knowledge. Here's the twist. It doesn't hold. In April 2024, a large international team, paleontologists, neuroanatomists, and cognitive psychologists, including Kai Kasper of Heinrich Heine University Düsseldorf and Christian Gutierrez Ibanez of the University of Alberta, publishes a detailed rebuttal in the journal The Anatomical Record. They go back through Herculano-Hausel's numbers and find the estimate was built on a shaky foundation. It assumes the brain filled the entire skull cavity, when in living reptiles like crocodiles, the brain typically takes up only around a third of that space, with the rest given over to fluid and connective tissue. It also scales T. Rex's neuron density using birds, its closest living relatives, when the team argues a more conservative reptile-based comparison, closer to crocodiles, fits the actual anatomy better. Once they correct for that, along with mixing errors between juvenile and adult specimens in the original dataset, the primate-level estimate collapses. Their conclusion: Tyrannosaurus rex was almost certainly working with cognition much closer to a modern crocodile than a monkey. To her credit, Herculano-Hausel doesn't dig in and defend the original number to the death. She's publicly welcomed the scrutiny as exactly how science is supposed to work. And that's the honest counterpoint here. Nobody can put an electrode into a 66-million-year-old brain. Every estimate on either side is built from an empty cavity in fossilized bone, filtered through educated guesswork about soft tissue that vanished long ago. The crocodile comparison is currently winning, but currently is doing a lot of work in that sentence. So the myth of the calculating, near-human predator mind didn't survive contact with rigorous peer review. But strip away the exaggerated intelligence, and you're left with an animal that still had to be big enough, fast enough, and strong enough to dominate its world without the brainpower to plan ahead. Which raises an entirely different question. Just how big was big enough, really? Mistake number 5 is a number everyone assumed was close to final, the size of the largest T-Rex that ever lived. For years, that title belongs to a skeleton nicknamed Scotty, unearthed in Saskatchewan, Canada, and estimated to have weighed close to 19,500 pounds in life, roughly the mass of a city bus. Scotty becomes the benchmark, the animal every documentary points to when it wants to show you the absolute upper limit of what Tyrannosaurus rex could be. It makes sense that scientists would treat Scotty as close to the ceiling. Fewer than 30 reasonably complete T-Rex skeletons have ever been found on the entire planet. So naturally, researchers assume the biggest ones, already sitting in museum halls, represent something close to the biggest the species ever got. Therefore, for years, the conversation about how big T-Rex could get quietly becomes a conversation about how big Scotty was. Here's the twist. In 2024, paleobiologist Jordan Mallon of the Canadian Museum of Nature and paleontologist David Hone of Queen Mary University of London publish a study in the journal Ecology and Evolution that attacks the problem completely differently, not by digging up new bones, but by running the numbers. Using population modeling based on an estimated 2.5 billion T-Rex individuals across the species' entire existence and mapping out a realistic growth curve, they calculate the statistical ceiling for the largest possible outlier the species could have produced. Their number, roughly 15,000 kilograms, about 33,000 pounds, close to 70% heavier than Scotty, potentially stretching past 49 feet long, heavier than 2 adult elephants standing side by side. But, and this is a big but, Mallon and Hone are upfront that this isn't a discovery of an actual animal. It's a thought experiment with real math behind it. Not one single bone has ever been found from a T-Rex that size. The number is a statistical projection, a reminder of just how small our sample really is compared to the true population that once existed. Paleontologist Thomas Carr of Carthage College, who wasn't involved in the study, puts it bluntly. With a sample size this tiny, we genuinely have very little idea what the true extremes of this species looked like. So the 70% giant is real in the sense that the math says it should have existed somewhere, sometime. But its bones, if they survived at all, are still buried, unfound, waiting. Which means the biggest T-Rex we've ever displayed in a museum still might not be the biggest one that ever walked. And if a number that basic, how big does this animal actually get, was still this uncertain in 2024, you have to wonder what else about T-Rex's own identity was sitting on equally shaky ground. As it turns out, almost everything. Mistake number 6 is the deepest one, and it doesn't just correct a detail about Tyrannosaurus rex. It questions whether every juvenile T-Rex you've ever seen, labeled in a museum case, was really a T-Rex at all. Picture a ranch in Montana's Hell Creek Formation in 2006. Paleontologists uncover something almost too dramatic to be real. A smaller, tyrannosaur-like predator and a triceratops, buried together, locked in what looks like the final moments of a fight to the death. The world nicknames it the dueling dinosaurs. But the fossil spends nearly 2 decades trapped in private ownership and legal disputes before finally landing at the North Carolina Museum of Natural Sciences, where scientists can study it properly for the first time. And there's a much older argument buried inside that small predator's bones. Back in 1988, paleontologist Robert Backer looked at a similar skull, this one held at the Cleveland Museum of Natural History, and named it a new species, Nanotyrannus lancensis, a pygmy tyrant living alongside the mighty T-Rex. But most of the field pushes back almost immediately. The bones look too much like a young Tyrannosaurus rex, they argue. More slender, fewer fused sutures, exactly what you'd expect from a teenager still growing into an adult's body. So for decades, textbooks and museum placards quietly relabel Nanotyrannus specimens as juvenile T-Rexes, and scientists even use those teenage bones to study how the species grew up. Here's the twist, and it's the biggest one in this entire video. In October 2025, a team led by Lindsay Zano of North Carolina State University and the North Carolina Museum of Natural Sciences, alongside James Napoli of Stony Brook University, publishes a study in the journal Nature built on more than 200 tyrannosaur fossils, with the dueling dinosaurs specimen at its center. Using microscopic growth rings in the bone, they search for something called an external fundamental system, a telltale sign that an animal has completely finished growing. They find it. The dueling dinosaur's predator was roughly 20 years old and fully mature when it died, at a size that, under the old theory, should still have belonged to an adolescent. On top of that, its skull carries more tooth sockets than any teeth. Rex of any age, its forelimbs are proportioned differently. Its tail has fewer vertebrae, and the pathways carrying its cranial nerves follow an entirely different route. Differences fixed from early embryonic development, not something a growth spurt could ever produce. The team confirms Nanotyrannus lancensis as a genuinely separate species, and while re-examining another long-debated skeleton nicknamed Jane, they identify an entirely new one, Nanotyrannus lithius. So for decades, every study that used a juvenile T-Rex to model how the species grew, hunted, or behaved may have actually been studying a completely different animal wearing a Tyrannosaurus rex's name tag. And the ecosystem itself looks different now, too. Instead of one dominant predator ruling the final million years before the asteroid, multiple tyrannosaur species were apparently sharing that same landscape, side by side. Still, this isn't the final word, even now. Some paleontologists who spent years defending the juvenile T. Rex explanation haven't fully conceded the point, and untangling exactly how many growth stage assumptions in the wider fossil record need to be redone could take years. Real science rarely closes a case this size in a single paper. It just moves the argument to firmer ground. So the sixth mistake isn't really about a smaller cousin at all. It's about realizing that even the identity of the king of the dinosaurs, the one thing that felt too basic to ever be wrong, had been quietly, confidently misfiled for almost 40 years. 6 mistakes. A posture torn down and rebuilt. A snarl that was probably a closed-lipped mouth. A loner that may never have been fully alone. A genius brain that turned back into a crocodile's. A giant we may not have even found yet. And a species whose own family tree just gained new branches nobody saw coming. Here's the thing worth sitting with. None of this happened because early paleontologists were careless, or because modern scientists are simply smarter. It happened because Tyrannosaurus rex is exactly what real science looks like when it's working correctly. Not a monument carved in stone, but a case file that stays open for as long as new evidence keeps arriving. We've spent over a century treating this animal as the one dinosaur we'd truly figured out, and every single decade, it's handed us a reason to admit we hadn't. So if the most studied predator in the history of paleontology could still surprise us 6 times over, with a new one landing as recently as 2025, what does that tell you about the animals we think we understand even less? What's still sitting out there, mislabeled in a drawer, waiting for someone to look again? We'll keep digging through those mysteries as long as you keep showing up for them. If this one cracked open something you thought you already knew, subscribe and come pull the next thread with us.